In this video, we are going to talk about two properties of logs and exponentials that actually go hand in hand. And really, all they are saying is that logs and exponential functions do and undo each other. They are inverses. Much in the same way addition and subtraction are, and multiplication and division. They do and undo each other. Okay, so the base of the log and the base of the exponential are both the same, in this case log base b. When I can, and b to the x, when I compose these two, when I do them together, where do I end up? I end up right where I started, at x. In a second, I want to pull up Desmos, and I want to go ahead and look at these graphs and see that they are symmetric about the line y equals x, because they are inverses. B to the, so all up in the exponent is log base b of x. Those things do and undo each other. We're just going to get x. The language is a little clunky. Log base b of b to the input. Oh, log base b of input and b to the input, those operations do and undo each other, which is why I just get my input. I just get x. Okay, let's go ahead and pull up Desmos and convince us that these things are inverses of each other. So here I have an exponential function, b to the x. Right now b is 6, so that's graphing 6 to the x, 6 to the input. And then its inverse is log base 6 of x, right? My slider here is set at b. Notice the symmetry about the line y equals x, right? I can show us that we literally are switching all the ordered pairs. The ordered pairs on red and blue have just been switched. And that's true if we have our growth or if we've got decay. These are still symmetric about that line y equals x. Just threw in that a line perpendicular to y equals x to highlight the symmetry here. Do you see how the ordered pairs have just been reversed? All right, let's highlight a specific one. Let's look at 2 to the x and log base 2 of x. All right. Don't need that guy anymore. Okay, see that it's symmetric about the line y equals x. And when I compose these with each other, these are the two properties that we just looked at. Log base 2 of 2 to the x will just be x. We're on that line y equals x. Similarly, 2 to the log base 2 of x is there. It's the same line. Okay, so all these are really saying is that logarithms and exponentials do and undo each other. Exponentials, b to the input, that whole thing up there is the input, and log base b of input, those do and undo each other. It is important that it's logarithms and exponentials with the same base are inverses of each other. Let's actually squeeze that in. With the same base, right? B, whatever that number is. They are inverses. No extra E. They do and undo each other. Let's just do a couple examples to illustrate these. So log base 2 of 2 to the input, right? Our log base 2 and our 2 to the input do and undo each other. We just get 5. Said another way that I've been saying is, what do logs do? Or log base 2, it takes in powers of 2 and it spits out the exponent. It's the opposite of 2 to the input of 2 to the exponent. All right, here's another one. 10 to the log of 18. Remember, if they don't write the 10 down here, that's secretly there. That's the base. And 18 is not a perfect power of 10, so I can't simplify that. However, I have the base of my exponent, 10. The whole exponent here is the log, right? And the base of my exponent and the base of my log are the same. Log base 10 and 10 to the power of do and undo each other. I'm just going to get 18. Right? So, these properties are used in question 4 and 7 in our 12.4 homework, and they're things that we'll be seeing kind of throughout our logs. It is important to understand that logs and inverses are logs and exponentials are inverses of each other. They do and undo each other.